Welcome to this second lecture on Introduction to Python. In this lecture, we will cover comments, variable types, Python collection, the so-called arrays, debugging, and finally, we will sum up everything that we have done. I would like to remember you again that this lecture series is available on GitLab, on the group page ByteMath Python Introduction to Python. Comments are fundamental when we are writing any codes on any programming languages because it helps you and other programmers understand the codes itself. In Python, to write our code, we start a line with the hash character, and everything afterwards it will not be considered by the Python interpreter, and thus it can be used as a comment. Note that the hash character is valid just for one line and not multiple lines. So if you need to write multiple lines or comments, you need to start each line by an hash character. As an advice we have to give you is the following one, which is ask a colleague or a friend to read your code, and on the points where they do not understand, just write a comment. Also, as a way to check if you have wrote sufficient comments on your code. Variables. So variables are the basic structure in Python, and I believe in every programming language, and they are designed as we use in mathematics to hold specific type of informations. There exist multiple types of variables, which is integers, integer number, is a float, which is just a float number, so natural number and so on, complex numbers, Boolean, which can be either true or false, and a Boolean variables not only can be true or false, but you can create a true or false even through if statement or logical conditions and so on, but we'll see later. String variables, which I would like to inform you guys that are arrays, and also any type or arrays, which just a variable to store multiple item or object. And to convert between variable types, Python have the useful functions with the name on the variable, so int for integers, float for float, complex for complex, and so on. To assign a value to a variable, we use the equal signs, and to check what type of variable it is, we use the type function. Look at the example. So we want to assign the value hello to a, so we are writing a strings. We write a, and then it appears hello. Looks that we are using Python shells in this case. Then I use the type function with the variable names inside the type function, and it appears class strings, as there is the strings variable. The difference between local and global variables is in which scope they are defined. What I mean, when we are inside a function, which we'll see in the next lecture, and we define a variable in that, this is a local variables. While if we define a variable outside a function, which means it can be used by multiple functions or for the entire script, that is a global variables. Use is not just the type function that we can use to check a type of a function. With percentage signs use, we can check all the variables that are in our namespace, and also the type and the values. For example, let's write a again hello, b 1.5, then use, and it appears something of this form, so variable A and B, because in our namespace we just have those two variables. Types, we have string and floats, because hello is a string and B is a float number. Data info, it says indeed hello at 1.5. So yeah, that's perfect. How do we print variables? It is fundamental to print variables for multiple reasons, maybe because we are printing plots and we need to write some information of that plots, or we are interact with the user, and so we want to give the user some information, and so we can have multiple reasons why we want to print variables, and there are multiple ways to do it, and the only one that I'm going to give you are not the only ones. So, but I believe they are the most used one. For example, let's write a variable named x. Notice that we are still in the Python shell. X equal to 1, then print the value of x is plus string, and appear the value of x is 1. That's just nice. In this case, we are basically transform the integer a variable x into a string, because we use the string function, and we are adding that string value to the value of x, because one of the nice things about string is that you can compose two strings together by the plus sign. Okay, now use another one, print again, value of x is like x. There's one of the basic one. Basically, we are splitting the printing function in two parts, one with a string and one with a variable. That's nice. Another one is to write the f before the text and write our variable names inside graph. So as we see here, another case, you use percentage signs, work as well. Finally, the format case. Again, we are writing our string phrase that we want to use. We put the x in the curly brackets and then dot format. And inside the dot format, we write the variables equal to what value we want. And yeah, those are some basic examples that we can use. But if you look online on python.org, you can find other ways to do it. With Python, we can do math, and that's a nice thing, are really nice things. Although we can only do math with integer, complex, and float. With arrays, unfortunately, we cannot do math. But we will see in lecture 5 that through the NumPy library there exists the NumPy arrays, which you can do math with those, but with least tuples, and so you cannot do it. But let's look at the examples. Okay, I'm still using the printing version that we have seen in the previous slide, and I define b and c to equal 2 and 4 respectively, and I just compute some basic multiplication, division, multiplications, addition, subtraction, the residue, and the power. And yeah, it worked this way. These results were done in the Jupyter lab. So yeah, if you want to see other inbuilt math comments, you just need to go to docspython.org and you can find all types of building math. Those that I show here is just the main one, let's say. Okay, arrays. What is an array? Arrays, as we've seen at the beginning, is just a way to store item and object. There exist 5 collection of data types called arrays, which are the list, a list of variable which is ordinary and changeable and allows duplicate members. Tuples, which is just the unchangeable, immutable version of list. Don't worry if you do not understand well what they are, we'll see soon after. Then we have set, which just as in mathematics is the collection on unordered and shareable members, and indexable because just the concept that we have in math. Frozen set is the unchangeable version on set. Basically, we cannot make any modification to it. And finally, dictionary. These set, for instance, a dictionary are mainly used in object-oriented programming, which we are not cover in this lecture series, but I thought it was really nice to inform you guys about these arrays. And dictionary, as the name tells you, is just a collection of variables and objects which you can change, and they are not indexable, but they're just a key that corresponds a value, like in the dictionary, basically. So, what is a list? A list, you can consider list as a vector type, but you cannot compute a mathematical operation on it. To compute a mathematical operation on it, as I said before, there are the NumPy arrays, which we'll see in lecture 5. A list is defined by square brackets, as we can see in the example. And the nice things about list is that each element, so 1, 2, and 3, can be any variable, any object that you like, and which means that list can be nested. You can make a list inside another list. What is a tuple? Well, as I said before, a tuple is the immutable, unchangeable variation or list. What does it mean? Immutable is basically mean that we cannot append it to it, so we cannot make larger the list, the tuple, sorry. We cannot change the elements, so we cannot reassign the values to the elements, and we cannot delete elements. Tuples are defined by brackets, and as we can see in the examples, again, as the tuples are the immutable version of list, they have the starting property on list, which means 1, 2, and 3 can be any variable that you like. It could be a list, it could be another tuples, it could be a string, and so on. There is no restriction to it. Property of list and tuples. So both list and tuples support indices, and slice operation. Indexes, it means that you can take the value of an element inside the list or tuples by asking the index, so the position there are in it in the list and tuples. For example, let's make the two lists, the list and the tuples, so the list 1, 2, 3 basically, and tuple 1, 2, 3. Then by indexing L square bracket 0, we are asking for the index for the element I index 0, which is 1. Indeed, it appears 1. For the tuple, it works in the same way. We still use square brackets, and again we get 1 because it is 1. If we want to slice operation, so we want to make a smaller arrays from our bigger ones, we just need to use the double dots, as we can see in the example. In this case, we say, okay, slice our bigger list. In the list, they start by index 0 to index 2 minus 1, so position 1, and we get the first 2 elements. Similarly, for tuples, work on the same ways, and we get the sliced tuple. Finally, we can also have the backwards order, so we had another double points and -1 in front, so we asking to have the list in backwards order. Similarly for table, the same way. Okay. Difference between list and tables. So we have seen the similarity between the two, and the main difference, as we have seen already, is that tables are immutable objects while lists are mutable, which means that we can change the element of a list. But how can we do that? Easily. Let's create our list, standard list basically, then let's change the value at index 0 to be equal to 20. Let's print our list again. Indeed, we have 20 right now. Or we can delete elements, and let's say we want to delete the first element, so in index 0, take in mind that Python, for any list, any arrays in general, the index, that any arrays that is indexable start at 0. We can delete with the del functions, the print L, and then we have delete versions. Similarly, let's make another arrays with the inbuilt appended function. We can add an element to the L list, and we print again, we have the 4 in front. But using the plus sign, we can add two lists together, as we can see in the example. In this case, we have not redefined L, so by using the inbuilt function extend, we can extend L in the same ways of the plus. So for make work to redefine the L list in the previous example with the plus, we just need to write L plus M. Basically, L equal L plus M. Okay, methods. Okay, those functions that we have seen before, so extend, appended, are called methods, and more precisely methods of the object. And they have the following instruction. We have object in our case was a list, dot the function that was before appended or extend, and the argument inside the function. What is the idea behind? Basically, the idea behind is that the arguments go to be is used by the function, and the function is applied by the object. An example is, as I said before, is the appended. Okay, strings are arrays, as I start at the start of these videos. And why is that? Because strings are basically a bytes of represent Unicode character. So a single character is simply a string of like 1. So H is a string, is character length 1, E character length 1, and so on. So for example, let's write s equal hello. Then I think about strings, that since they are arrays, we can also, and in particular they are indexable object, we can use the same slice index operation of lists and tables. Indeed, we have write s to equal hello, then index at position 0 h. We slice the first two elements in our strings, which e basically. Finally, we can have inverse orders, so same operation. Notice that those are not the only slice operation. If you go to doc at or python.org, you can find additional slice operations. Inbuilt functions and methods. So, like appended for list, string and tables have also inbuilt functions, called methods. And an example is the len functions, which work for any arrays, and it returns the length of the arrays in the case, let's write, let's consider our string hello, at least 1, 2, 3, and 2, 1, 2, 3. Then the len of S is 6, because we have 6 elements. The len of L is 3, because 3 an element, and again, the len of C is 3. Nice. You can find more methods on docspython.org. Mapping and set. Mapping and set are mostly used, as I said at the start, for object-oriented programming, or OOP. Dictionary and mutable object, while frozen set are immutable. Let's consider a set is defined by curly brackets, like in the example we see here. We call as, indeed, appear. Frozen set, you use the function frozen set. Inside, you use the square brackets. Note that also for set, there is the set function that works in the same way from frozen set. And again, we printf. Dictionary it has this form, so curly brackets again, but the difference from set is that we give a key to each element. So for example, to element 1 we give the key A, element B we give element 2 we give element B, and so on, and we print if we have the set. Mapping and set. Dictionary has the following characteristics. Dictionary, as I said, are mutable. They're dynamic because you can make long, bigger, or shorter. They can also be nested, like list and tables. The main difference from list, because they're really similar to list, is, as we've seen in the previous slides, that lists are accessed through indexing, while dictionary are accessed through keys, which means that to call a dictionary elements, you need to use the key element and not 0 or so on. So if you give the name key, as we said before, to A, you need to write D square brackets A, and you will appear the element corresponding to A. Additionally, you have multiple properties on dictionary, and you can even restrict the type variable of a predefined keys. Example, let's have a lunch rating, an empty dictionary, then we add a key element called Greek olive, and we give a value of 10. Let's add another key element, it's called aula, and give as a string, so expensive. Lunch rating, again as before, so on. Then we call the key element corresponding, the key value corresponding to the key element aula, and indeed it appears expensive. Lunch rating, we can change the value of corresponding to a key element, even by using list or tables or any variable that we want. And in this case, let's change by good and 10. In the appear, there is it. Okay, finally, our last topics, debugging. Debugging is something that you're going to do a lot when you're programming, because basically you try an error when you write down a code. Python has a lot of characteristics in this regard, and in particularly every time that you get an error message, you're going to have an error box that is in Python is called traceback, and the traceback has mainly the three characteristic, which is the type of error. It gives what type of error it is, where the error in your code occur, or which line, and that he also try to explain why that error occur. Often for the last point, you need to have a little bit of practice, because traceback are usually quite compact, so the information are given in a compact way. So it's just a way, a matter to search on the internet for the error that you get to figure it out as at the start. Okay, an example in this case, I wrongly written the function print, and thus I get a syntax error, which basically when you got a syntax error, you have the line say, okay, oh, you make a mistake on the syntax, you need to correct the syntax. And as you can see, it informs us in which line that appears, where it appears, and the type. Okay. Sometimes you want to use to think ahead of possible error, and you can use the try except format. It basically say, okay, you tell the program to try to do something in case raise an error if that occur, and if that occur, do something else, as we can see an example here. But you can find more information on python.org. Okay, summing up what we have said in this lecture, we define the variables, we learn how to define variables by means of the equal signs. Python have multiple types of variables, interval, float, ball, and so on. And arrays, in particular, most important one. And you can change bin to var by using the anonymous names of the variables. Then we learned the list versus tool, which lists a mutable into an immutable. We also seen the difference between set and versus set and dictionary. But yeah, the difference between list and dictionary, which is the how we call value inside the dictionary and how we call it inside a list. We also learn how to do comments, which is fundamental for any programming language. For Python, I would advise you to follow the pip8 Python style guide. And finally, we learn how to debugging, how the debugging works. Basically, you're going to have, every time that you got an error, is going to have a traceback, which contain mainly three factors: the error type, the error location, and the reason for the errors. The error type, there is the entire list can be found on python.org, but I would not advise to read through all at once, but rather every time there appears an error, just going to check if you have any kind of doubt. Thank you for watching this lecture. I hope to see you next one, which is going to be on program flow controller, and enjoy.